that was a great triumph for the early quantum ideas about the structure of the atom. We now knew that light is coming in discrete packets. Already people had discovered the existence of electrons. J.J. Thomson in 1896 had proven them. In fact, there's a famous thing where Thomson was brought before the British Parliament and asked, of what use, sir, will your electrons be? And Thomson famously replied, someday, sir, you may tax them. And indeed, we do tax electrons quite a lot now, for sure. So we knew that atoms, matter was made of atoms was the idea, and you had electrons, which are negatively charged inside an atom. But where was the positive charge? Well, one of the ideas actually came from Thomson himself. He said, well, an atom is like a little ball, sort of like a raisin cake with a ball of negative charge with little positive raisins inside it. Okay? So Rutherford wanted to test that idea. Rutherford was a big, burly New Zealander who had scientist and chemist, physicist and chemist really, who made his way from New Zealand to Cambridge University, and in 1909 was studying the properties of radiation and trying to elucidate the structure, the atomic structure of matter. So what he decided to do is shoot alpha particles at a very thin gold foil. Now, at that point, they called the different kinds of atomic radiation known alpha radiation, beta radiation, and gamma radiation. We now know that gamma radiation, which can pass through a lot of material, is actually high-energy photons emitted by radioactive nuclei. Beta radiation is electrons, which are also emitted by, again, heavy radioactive elements. And then alpha radiation, which you can stop with just a very thin piece of paper. Alpha radiation is, we now know, 2 neutrons. It's an alpha particle is 2 neutrons and 2 protons. It's really a nucleus of a helium atom. But there are very heavy elements like radium that shoot out, when they undergo radioactive decay, they shoot out alpha particles. It's alpha decay of unstable nuclei. But that was not known then. They didn't even know the nucleus existed. So this is how the nucleus got discovered. We shot alpha particles at gold and saw them bounce off at high angles. Well, if Thomson had been right, and the atom actually had little raisins of positive charge somehow distributed inside the nucleus, then as an alpha particle passed through an atom, it would just get rattled a little bit because obviously we knew that it was shown already that alpha radiation was charged particles and it was positively charged and it had a certain charge to mass ratio. All that stuff was known already in 1909. But if the positive charge was distributed throughout the atom like a raisin cake, the alpha particles should have just gone basically straight through. Now, the way the experiment was done itself is an interesting story. Okay, so you have a very thin gold foil, you have your radioactive source and a nice collimated beam of alpha particles. Then you go into a dark room and you put up a phosphor screen. And Rutherford's graduate students carried out this experiment. The phosphor screen will flash every time an alpha particle strikes it at a certain spot. And so they measured the number of alpha particles striking different parts of the screen. And what Rutherford expected to see is that after passing through the gold foil, the alpha particle beam would spread out a little bit due to scattering off the positive charges inside the atom. To his great astonishment, his students, Geiger, the guy who invented later Geiger counters, and Marsden went into this dark room and they let their eyes adjust and they would, for hours, record the positions of the little flashes on this phosphor screen. And they came and showed Rutherford their data. He said, nonsense, that's completely impossible. So he went in there with them and observed with his own eyes the same thing. And he said he was utterly astonished. It was as if he took a cannonball and shot it at a piece of tissue paper, and it came back and bounced off it, bounced off the tissue paper and hit him. His genius was to realize what this meant. That the only way a heavy, dense, positively charged alpha particle could bounce back at such a high angle like that was if there was a very tiny nucleus at the center of a gold atom. And he went off and worked furiously for the next 24 hours, according to his own accounts, deriving basically from first principles the idea that you have two positively charged things that are colliding, and one of them is heavy and one of them is light, and you get a very high angle scatter like that. You can actually take that physics calculation. It's now a famous calculation that we have our students do when they're studying classical mechanics even. You can take that calculation and calculate the size of the atomic nucleus. And he got a value astonishingly small, 10 to the minus 14th meters. It was already known that atoms had to have a size of about 10 to the minus 9th meters, 10 to the minus 8th meters, something like that. But this was orders of magnitude smaller than that. If an atom were a cathedral, the nucleus would be a tiny grain of sand in it. That's how small the nucleus inside every atom is. We often hear it stated that atom is mostly empty space. Well, we'll see what it looks like in a little bit. But most of the mass of an atom is contained in the nucleus, and that nucleus is incredibly tiny, 10 to the minus 14th meters. So this was an amazing discovery. One of the most important discoveries in early 20th century. Interesting stories. I had the opportunity to visit Christchurch, New Zealand back in 2001. Went to a conference there. It was really a wonderful place to visit. It was right around when the Hobbit movies and the Lord of the Rings were coming out, so New Zealand was an interesting place to see. You can go there and see the places where they had the horses riding through the plains. Never mind that, but there's a museum in Christchurch devoted to Rutherford, who is, their most famous son, I guess you'd say. And I'm looking around all the different things that Rutherford did in chemistry and science and all this. There's nothing about his discovery of the nucleus. And I realized, and then talked to one of the curators of the museum, New Zealand is a very rabidly anti-nuclear country. They don't have any nuclear power. They don't allow nuclear submarines or ships to dock in their ports or anything like that, and just sort of forbid it. And it's as if they tried to erase nuclear physics from the history of their most famous scientists to ever come from New Zealand. So, it goes to show you, careful who you have write your history. And always take history with a grain of salt.